looking at a roadmap, we are in the idea of looking at how, like the techniques of getting into approaching safety problems. This is a little bit project level and a little bit network level. There's both that are mixed in here. Specifically today, looking at the ideas of designing versus putting countermeasures in, nominal versus substantive safety, systemic versus systematic treatments, spot treatments, safe system approach. It's not clearly delineated in this, but these are the ideas that we're going to be focusing on. So as we get into it, how to approach the safety problems, I want to talk about, like, understand that countermeasures are only countermeasures if they're not originally included in the design, right? So countermeasures are when we come back in later after a problem is already started and then try to fix it. What we want to be doing in addition, I mean, there are issues we need to address like that, but what we also want to be doing is making sure that when we design it in the first place, that when we get the facilities out there, when we're in the operation portion of it, that we're using strategies, techniques, designs that keep issues from occurring from the beginning. Understanding the difference between nominal safety and substantive safety. The difference between designs, knowing the designs are also design features, fatalities, understanding what spot treatments are. Spot treatments are usually what we're normally thinking about when we talk about addressing crashes and why they're sometimes appropriate, the difference between systemic and system-wide approaches, understand what best practices are, and once again, the safe system approach. So how do we approach safety? So for this level of class, I'm going to break it down into really like 6 different ways, right? The systematic, site-specific, systemic, the predictive method, risk factor mitigation, and the safe system approach. And the safe system approach is really kind of cheating because it covers all of it. And this is when we're going to get text heavy, right? So we're going to try to get out of the text in the future conversation, but this is where we got to really sit down and nail down the definitions. Once I get through these definitions, there'll be a time for questions. So if you see something, go ahead and raise your hand, and that way we're kind of queued up for the discussion portion right after the end of this specific session. So the systematic approach is essentially your design standards. It's dictating a set of safety features that are applied across the roadway network at any location that meets the criteria. So whether that's the FDM, MBTCD, the ASTRO Green Book, etc., they're features that provide a level of safety when employed, but they stop providing additional benefit at certain risk levels. Dwayne Carver used to say, the design standards are like a box of crayons. Like, you've got to decide what color you're going to make it. You've got to decide how many colors you're going to make it. The design office has done a phenomenal job at increasing what's available in the FDM to our designers to be able to solve the safety issues. But understand that there's still a judgment call that needs to be made, right? Because the FDM offers usually a range of things that can be done. There might be a design minimum or design maximum, but that doesn't mean that there's not often a way to flex in between. And that's where the engineering judgment comes in, right, in the design. Some of these standards too determined through either a judgment call or a statistical analysis, meaning they don't necessarily cover every situation, and can't always be relied on for a fatality-free system. We'll talk about the CMF clearinghouse when we talk about crash modification factors. You still have to get into, like, how was this developed, right? Because we talk about it. Certain districts have this more than others, but back to my experience, like District 1, District 5 as well, you've got very urban areas, but you also have very rural areas and a lot of suburban areas. So what works in one area may not work in another, and you've got to be flexible with what you're doing and how you approach each one. These are what I would classify as your foundation, your good start. They are applied freely throughout the system when you meet it, and it gives you your baseline of safety. Site-specific approach is your, like, hotspot or high crash locations. These are the ones we're probably most familiar with, where there's an evaluation that's been done. And it could be, someone told us about location. It could be a network analysis. You could be on a project identifying a specific issue. Last session we heard about a train issue, like a rail crossing issue. So that would be your hotspot analysis, where it's substantive safety, and what you're doing is you're looking at this specific issue that's at this specific location, and here are these specific countermeasures or design features needed to address that historical crash issue. It's all based off of historical crashes, and actually having the data to look through and say and try to figure out this is what is leading to this problem. Therefore, let me apply these features to solve it, or reduce the consequences of the decision if you can't completely solve it. The systemic approach is largely a network analysis combined with risk factors. So it's not focused on crashes, right? Risk factors could be vulnerable populations. It could be high-speed roadways. It could be poor lighting. So for instance, if you look at rumble strips, right? Being able to say, hey, we know that 2-lane rural roadways over 55 miles an hour are susceptible to lane departure crashes. So we're going to make sure that we have a certain size shoulder. We're going to make sure we have rumble strips, and we're just going to go with that. I think the example here, bright sticks on chevrons, like we have chevrons already, but a low cost would be putting in the bright sticks or optical speed bars. But it's the idea that you're not necessarily looking for crashes to exist before you do something. You're saying, hey, like this area here, I'm surprised that there aren't crashes because this has the features that typically lend themselves to crashes. So I'm going to go ahead and put some stuff in right now that's fairly low cost, but I can apply it throughout my project, or I can apply it throughout the entire district. A couple examples are the incident in the state is we did the rumble strip initiative. We have the wrong way driving initiative, and we also there's the railroad dynamic envelope. Those are all, I think, pretty good examples of systemic safety that the state has applied. The predictive method. It's a scientific method of looking at roadway characteristics, crash history, design features, and potential changes to predict future crashes. It's used to determine theoretical effectiveness of design choices to help make better decisions. PD&E, for instance, would be a good place to use this, right? So if you're let's say you're doing a 2 to 4 lane widening, you're changing the character of the road. You have a 2-lane unseparated road. Now you have 4 lanes with medians. The character of the road is completely different. So how do you get out ahead of the crashes, right? You're not trying to put any risk factors in there with your design. You're doing good systematic design. But how do you get out ahead of it? And that's using the data, the SPFs, the empirically collected data then they provided the equations to go back and say, okay, if we do this, we predict that we're going to have this much of an increase in crashes or this much of a decrease in crashes. And that leads to your decision making. We are not going to cover that here. I just want you to know about it. Risk factor mitigation. So this is closely linked to both the predictive method and the systemic method, right? Because you're having the risk factors, which in the predictive method, those risk factors lead themselves to the data and equation inputs when you're working through the Part C and the HSM. Risk factors are also a part of a systemic analysis. But I'm calling this out specifically because it's also a part of a project level analysis. To where it may be something that's more expensive, right? We've done recently the root cause analysis, and we'll go through some of that, looking at lane departure and bike ped. So if we determine we have one of those locations, making sure that we put it in. A good example I've got here, right? You have a C3C context. So we know we have pedestrian issues in C3Cs. 6 lanes, we know multiple lanes increases the crossing distance. We also have we have issues there. 45 mile an hour speeds. We know 45 mile an hour is a risk factor because at 45 miles an hour, you have an extremely low, I think it's like 5% survivability rate as a pedestrian if you're hit by a car. You have transit, attractors and generators on both sides of the roadway. So we know pedestrians are out there. And your pedestrian crossings are only signalized at intersections that are half a mile apart, which means that if you're in the middle of those signalized intersections, you have to walk a quarter mile to the intersection, wait, a couple minutes for your phase to come up, cross the roadway where you're dealing with multiple conflicting movements, and then walk a quarter mile back to get to your destination across the roadway from you. You're probably not going to do that. You're probably going to cross right there, right? So making sure that even if you don't have pedestrians, a pedestrian crash issue yet, you're understanding that those crossings are happening and that we do need to make an effort to make sure it's protected so that we don't wait until there's a problem and then have another 5 years to get through the work program to make sure to get to a solution, right? And then the safe system approach. So the safe system approach is using a lot of almost all of that, right? But then the other part of the safe system approach where it takes it to the next step is into implementing layers of protection, where you're saying we have the risk factors, we have the historical crash analysis, but we're going to go ahead and we're going to put speed calming countermeasures. We're going to go ahead and we're going to put conflict point mitigations in there. We're going to do these things and tie it all together. So here's the big stop in the beginning. Out of all of that, I know that's a lot. Are there any questions about the different types of analysis? Just one? All right.
Nathan,
Yes, sir.
devil's advocate, what's the
right
way to do it?
Safe system approach. Because it's all of it.
I thought you were going to say depends.
Depends, yes. I'm trying to think if there is a better answer. It's the answer is the technique that gets you to zero. And I think all of them have a place in it. And I believe I saw, sorry, I can't see who has their hand raised, I don't think. I thought I saw Lori pop up.
Yeah, that's what I saw too.
I did, but then I started typing it. For predictive, is that project level or corridor wide? Or I don't really. Will you clarify, please?
So that's the Highway Safety Manual Part C. It's generally used on a project level because you have to have a defined set of characteristics that you're comparing before and after to. So for instance, let's say you're making an argument for funding for lighting, right? So you can go in and you could say, hey, I have X number of crashes. If I put lighting in, it's going to have this number of crashes. Here's the benefit cost ratio for my project. The citing, and it does get simplified in the end, right? Because especially like when you're at the PD&E level, like there's only certain just decisions that you're making at that level, depending on how far you go. But it is helpful to be able to quantify those decisions. So whether you are defending a decision or gut checking what you're trying to do, whatever else, it's a good way of making sure that you are not going to make a decision that has a negative impact on the safety of the corridor. But you would not use it necessarily on a network analysis. I had seen, so Joe, before Brenda, Joe Santos was the state safety engineer, and he used to send out a network analysis using the empirical Bayes method, which is excess expected crash frequencies, which is similar, but it still required that analysis to be done at every corridor once they've been identified from the network level. Any other questions?
I was just going to note that kind of related to the different approaches you could take. There's value in all of those approaches, and so depending on where you're at in the like at a program level versus a project level, and where you might be in the project development process, you may lean more heavily on one of those approaches more than the other. So taking a systemic approach, we're working with the state safety office looking at statewide issues like lane departure crashes, taking a systemic approach, which is going to focus on identifying risk factors associated with crashes, and then treating that is a good approach. But if you're doing a project for a 5-mile corridor, yes, you want to look at risk factors, but you also do want to consider where's the history of crashes been on this corridor, and are there specific issues? Nathan's going to get into substantive versus nominal safety here. Are there specific issues that we need to address at a particular location while we're doing this project?
That's a good point. Of the different the 6 different methods that we were talking about, if let's say you're a design project manager, or a designer, you're going to be looking at risk factor mitigation. What are our risk factors that have been identified on the project? Can we solve? You're going to be looking at a safe system approach. You're going to be looking at a site-specific analysis, because you're going to pull the crashes and you're going to look through the crashes and solve them, and which is what we're going to do in our workshop mostly. And you're going to have systematic, because you're applying the design standards. And depending on your project and how you feel about it, and whether it's the right case, you may use the predictive method. Chances are you probably won't. But those other, the systematic, the site-specific, risk factor, and safe system will probably all be ones that you will use on that particular project. If you are in traffic ops, you're honestly going to use most of those as well. It'd be most of the same ones. Where the systemic is usually you'll see that out of the safety offices and out of central office, because they're going to be the ones that are doing the safety specific projects quarter wide, unless you become a designer on one of those specific projects that they identified. And then Lois?
I just, one thing to keep in mind is what our partners are doing. I'm thinking, like, for example, the Palm Beach TPA has a high injury network they focus on, and they're working on a speed management plan. So the wider scheme of things, how are other partners viewing the transportation system, including state roads? It's another part of the picture.
Certainly is. And I think we've, different districts have actually done a lot of work working with local partners, because depending on where they're from, they've got different ideas of what needs to happen, right? US 27 through Sebring, it is not a local road. It is very, very built out, like one step below limited access. Previous commissioners wanted throughput. They wanted the trucks getting through. They wanted it to be a major arterial. Commissioners later wanted it to be a local road. So you start getting that clash. But they have done a lot of work with that, and it's really good. Like your TPA, to be able to have partners that have a mission and help lend the support on your projects as well, to say, yes, we want these features. Any other final questions on this? All right. Nominal and substantive safety. So this is probably one of the really big ideas when we start getting into project level. There we go. So standard plans, the FDM, like this is your nominal safety, your systematic. So we called it systematic before, right? Because it was a type of analysis. Right now, we're talking about levels of safety. So this is what's called nominal safety. They're helpful. They don't ensure safety. If you only design to the minimum, we're still going to have issues, because it takes more than the minimum cannot ever encompass every situation. It just can't. We're going to do as good as we can to give that box of crayons to you, but we cannot cover every situation you're going to encounter. It takes designing over the minimum requirements to effectively address safety, and that if they're not up to current standards, go ahead and bring them. But the idea is that we're getting a kind of a baseline. Like, we understand that this is the line that we're getting, and we're going to get this baseline of safety, and then we work over that. So whether it's your manuals, the Asher Green Book, Floor Design Manual, METCD, getting in the TEM, just whatever that design manual is, understand that if it is a manual, it is nominal safety. Meeting this, if you're only doing nominal safety, then you would say that yes, this is safe, right? This does everything. But it doesn't actually get down to characterize actual conditions, actual experienced crashes, things like that. It's just doing that it's part of the older approach. When we talked about like the Vision Zero versus the new approach, it's that older approach of the road is technically designed correctly. So if you're experiencing a problem, it's because of the user. And we're shifting that, right, to saying, hey, no, we have responsibility in how the road's designed because we know the design decisions we make have a negative or a positive impact. And since we know that we have that impact, it is our responsibility. And that's where substantive safety comes in. And that's your actual or expected safety, looking at severity of crashes, crash types, crash rates. It's evidence-based, and it can be the minimum standards, but it's often above the minimum standards as well. So nominal safety, if we look at a curve, right? This is your nominal safety. This is the application of safety signage per the MUTCD criteria. You know, we have our arrows, we have our curve chevrons, we have our advisory speeds, our advanced curve warning speeds. Everything is here to make that curve safe nominally, right? And it is. Everything here, there are signs and standards that we have learned that we can apply very broadly that do provide a positive benefit. You know, we've learned through experience chevrons work, right? We've learned that advisory speeds are necessary because sometimes the horizontal curvature and the super elevation is not appropriate for whatever speed people are traveling. But we also know that these are not foolproof, and we know that people still drive it in ways that it doesn't work, or maybe they're not paying attention. We just did a study in District 5 for Tony Nossi, where this exact situation was there. We have a situation where all the correct signage is there. It's on a local road. But people are still getting fatalities. People are just plowing through the curve. They're not seeing the signage. The retroflectivity is good. Everything is there. So that's when we address the substantive safety. We take that MUTCD application and we start adding signpost covers to increase the visibility of the chevrons. We add optical speed bars. District 1's used those a bit, or has started using them, and they've seen good success on that. I didn't include in this slide, but you know, in that instance, we also had a dynamic curve warning system where a radar senses the approaching vehicle, and then LEDs and the signs light up in a sequential pattern through the curve to guide the driver. It's the idea of getting their attention and guiding them through the curve so they don't just plow through it and hit it and strike a tree, a fence, whatever hazard is on the other side. So, right, so nominal safety is the standard, the MUTCD or whatever you're working off of, and then substantive safety is that little extra step to make sure that we are actually addressing the problems that are happening, and we're doing what we need to prevent those crashes. This is a good graph to show it. So substantive safety is a continuum, right? So we have crash risk and design dimension, and we're just looking at lane widths. And don't take this that, you know, 11 and 12. This is for a very specific situation, right? There are situations where 11-foot lanes are better than 12-foot lanes, that 10-foot lanes are better than 12-foot lanes. But in this example for that situation, we can see the crash risk is that for 11-foot lane and then drops for a 12-foot lane. But then once it gets to that 12-foot lane, there's no additional benefit. And this doesn't take the curve out further, but the idea is that your substantive safety is it's not just going to be a binary, you know, it's either 1 or 0. It's going to be looking at the continuum through safety. And when you add it, this one doesn't show it added, but when you add it to your nominal safety, we're taking it that little extra step to make sure that we are getting, we're smoothing out that curve, we're making that curve dip down, so we're addressing all crashes and not just the minimum. So this is another example of a roadway, right? So with these roadways, it's not a Florida roadway, so we're not going to get the Florida standards, but the idea is that each of these alternatives that you see on the screen technically meets a design standard, right? They're all designed by the standards of that location. 5-lane sections are perfectly acceptable. You know, parking off the sides is acceptable. All of it is nominal safety. But then we see in alternative 1, you know, we start adding some better signing and pavement marking. We added extra space for pedestrians. There's a little bit of an interrupter island there in the median. Alternative 2, a transit lane. We start adding some more medians. And alternative 3, more solid medians. You see some roadway lighting, better signing and pavement marking, kind of cleaned up the access management on the sides. So it looks like there's some street trees and some pedestrian facilities. So the idea is all of those are substantial, or substantive safety versus the nominal. All of these are nominative safety. Substantive is getting into alternatives 1, 2, and 3. It's taking it a step further over the design standards. And you see it when you start looking at the predictive analysis. So, these alternatives are made up, but they were done using a predictive analysis. So you're looking at 26.3 crashes a mile and 4.2 crashes a mile when you start doing the HSM Part C. And it shows the difference between just meeting design standards versus making decisions and going to that substantive safety that take it a step further. So just a reminder, nominal safety is addressed by compliance with standards, warrants, guidelines, and sanction procedures. You are putting the bare minimum in. Minimum signal phasing, whether it's minimum design, minimum signal phasing, minimum warrants. Substantive safety is addressing and treating the actual crash frequency and severity for roadways and highways. Any questions on substantive versus nominal safety? And someone give me a good example of how you would deal with a pedestrian crossing with that's both how you would do it with nominal safety and then how you would do it with substantive safety.
Adding high emphasis lines.
That
Would that be an example of substantive safety?
Yeah, if it was a location that you're putting a crosswalk in that does not require high emphasis, and you choose to put high emphasis in, that would be substantive safety.
So like, no, nominative would be just putting in a crosswalk, while substantive would be like putting in a raised walkway over the road, right?
Yes,
Like
that can be.
pedestrian bridge. Okay.
And in some cases, putting in the crossing anyway may be substantive, right? Like if we're not meeting a certain criteria for putting it in, but you know that there is a need, even if the criteria is not met, putting that crosswalk in anyway could be considered substantive safety.
So does this encompass the beacons that pedestrians can hit to send flashes to have people stop, or you hope they stop?
I think it depends, right? So let's say you don't get your 20 pedestrians an hour that warrant it. If you have the 20 pedestrians an hour and you put your beacons in, that would be nominal safety. If you do not, but let's say you have a bus stop on one side of the road and there's a Publix on the other, and everyone stops that gets off that bus, goes across the street to Publix, and they don't go to the next signal. But there's not enough pedestrians an hour to actually warrant some sort of device, whether it's an RFB, PHB, whatever. Making the decision to doing it anyway would be your substantive safety, because you understand that even if it doesn't meet that arbitrary 20 pedestrians an hour, there's still 5 people an hour that are deciding to cross 6 lanes of traffic on their own.
Nathan, a good example I think might connect with it's a statewide example, so I'm sure some folks in the district have dealt with this, but probably 8 or 9 years ago, we did a statewide wrong way crash study for central office that looked at the wrong way crash problem throughout the state. And eventually what came out of that is we upgraded the standard for the ramp terminal intersection signing and marking package. So what was previously the standard was, one set of wrong way signs and do not enter. And then, which was basically the minimum that the MUTCD required. And as a result of the work that we did, we actually upgraded the standard. So now you have multiple sets of wrong way driving signs, do not enter on both sides of the entry with one way. You have pavement markings that tell you, which lane you're in that's going to lead you to what direction on the highway. You have more no turn signs on the signal mast arms and things like that. Those were all optional signage and pavement marking packages from the MUTCD, but we made those the new standard for FDOT. So we actually took the nominal safety and we took it up a notch. Now the new standard is more safe than the old standard. But then in addition to the new standard, there are other things you can do, right? So we had this statewide wrong way driving countermeasure implementation where you're putting ITS devices at some interchanges. You're not doing it at all of them, but you're doing them at where there's more risk factors, different interchange configurations where you are seeing more wrong way movements being done. And so I think that's a good example of where you have nominal safety was meeting the new standard. Substantive safety was meeting the new standard plus adding some of these other things in there that were addressing, context sensitive risk factors.
Any additional questions? This is a kind of an important idea to make sure that we're understanding. Does everybody get right now the difference between the two and why it's important? All right. So we're going to move into systemic versus systematic. Oh, Greg.
Yes, thank you. Yeah, I had just a question. This was just about like on the triple R projects at FDOT. So I know we would have the nominal safety improvements proposed, but do you know if the substantive improvements could also be included in the triple R?
They are. So I'm going to answer, but I'd like Tracy to clarify because I know the policy has been changing a little bit. But the intent of the original 3R policy was to be substantive, right? So the idea of original 3R is that everything is, everything's up to standard. You're just replacing in kind with standard, which is your nominal safety. The idea between that new policy was to go in and do the safety analysis and make sure that there's an idea of being efficiency in the construction because since you're already out there, you're already mobilized, we're already touching the roadway. Let's just go ahead and fix what's there before we leave so that it's that future-proof idea. So if you are going in, that is not doing extra, that is the substantive safety, and it is what was originally encouraged. Tracy, I know we've backed off on every project due to funding, and they've talked about based off a high crash list. Do you know where that is now? Is she on the phone? I think Tracy's on the phone, so we'll ask her when she gets back off. What's that?
Yeah, can you hear me?
Yes.
Okay. So the high crash location list we were required long time ago, like decades ago, required to kind of study every like 5% of the high crash location list, and after that it was not a requirement, but high crash location list has always been a great reference for us to identify locations, and it's based on the historical crash data. Did I answer the question?
It was about, I think it was really good with looking at the high crash list. We're also looking for what the current policy is in District 4 for incorporating safety in 3R projects.
Oh, so yeah, based on the design manual and safety review is always required. for well for all the 3R project. But to what extent it has lots of flexibility for the district to make the decision what kind of extent we want to do and who's going to fund it. It doesn't have to be safety fund, and it doesn't have to be 3R fund. It could, based on the situation and also the type of the improvement, it could be funded by different funding resources. But to review the safety for the project limit is a requirement. Yeah, so in District 4, we have been doing that for every 3R project. But for the implementation, depends on the funding availability. So sometimes it's funded by safety, sometimes it's funded by 3R funding, and sometimes if some improvement, like short-term improvement, like payment marking, signing, or maintenance type of improvement. So we directly coordinate with our district offices, like traffic ops or ops centers, for them to implement those short-term improvements quickly.
Did that answer your question, Greg?
Yes, thank you. I appreciate it.
Thanks for asking. All right, systemic versus systematic. And I'm going to use the word systemic here. Remember, systemic is based off of risk factors. So we're going to go through some risk factors. One thing to keep in mind is these risk factors don't have to be solely applied on systemic projects, right? They can also do the risk factor mitigation. So if you see these on one of your projects, we can also do the risk factor mitigation on a project level and solve it as well. So even though the vernacular we're using is systematic, just understand that that risk factor works for risk factor mitigation. So systemic is proactive, using proven countermeasures, focuses on crash risk. The systematic, right? Systematic and nominal safety are linked. That's design standards. It's system-wide, applied to all locations that meet a certain standard. You might not, you might not apply certain warning signs at every horizontal curve, but you might at horizontal curves in rural areas with speeds over 45 miles an hour. Or putting bright sticks on stop signs where it is dark, unlit, low volume, high speed rural locations. If you put bright sticks on every stop sign, that system-wide, that is a systematic. That starts to become a systematic thing, because while it might not be a design standard, it starts to become a policy, right? So looking at it, it means an improvement. This is the official definition, right? Is widely implemented based on a high-risk roadway features that are correlated with a particular crash types rather than crash frequency. So what this means on your projects is when you're doing systemic or you're doing risk-based analysis, you're putting safety features in regardless of whether the crashes are there currently, right? Because a lot of times, if you think about it, like a really simple example, you have a rural road, nothing's changing in the character. It's going for miles, 2-lane road. There's no curves. There's, sporadic houses. Nothing else is there. You get run off the road fatalities, and they're also sporadic. There's one over here, there's one over here, and there's nothing that you can find that indicates what happened. It's not like they're all clustered on an intersection or a horizontal curve. Systemic shines in places like that, because you're saying that, we're not sure exactly, like we can't pinpoint something that's directly wrong, but we know what those risk factors are. So we're going to go ahead and address them with something that's low cost and widespread. So using lane departure again, some of the risk factors we start looking at historically have been number of lanes, the lane width, the shoulder width and type, median width and type, driveway density, roadside. When the roadside means like what's on the roadside, horizontal curvature, super elevation, delineation, advanced warning, speed differentials, and visual traps. You can put different weighting on each one based on where you're at and what you're experiencing. But the idea is just giving examples of things that need to be looked at when you're on a project level that'll help contribute. Shoulder width is a big one, right? So the idea of a shoulder is that if you leave your lane, you can recover safely. We talked about the head-on crashes. One of the problems if you don't have a shoulder and you have a big lip on the asphalt, or you have over tracking or erosion on the side of the road and the wheel gets caught, trying to get the vehicle back on the roadway, a lot of people pull the wheel a little bit too hard and it ends up slinging them into oncoming traffic or off the other side of the road as an overreaction. So things like that, looking at shoulder width is being a risk factor. When we start breaking down the root cause analysis, and we'll go into this in the actual lane departure session as well, we start breaking down, it's just general information about what's going on. Fixed object run off the road is the biggest contributor. Basically, we went off the road and we hit a tree, we hit guardrail, we hit whatever the guardrail needed to be there to protect. Had a 10% head-on collisions, 9% are side swipes, 9% rear ends. I imagine that's mostly, same direction, but you're doing lane changes, and 6% angle. By and large, though, the significant amount of them are going off the road. You add the 10% head on, 62% of the crashes are really, really leaving your lane and running into something else. So when you look at, and if you remember correctly, 44% of fatalities are based on lane departure. So you can say 20% of our fatalities are based off of leaving your lane and hitting someone head on or hitting a fixed object. And when you start boiling it down, you start seeing what the real risk is for those, to make sure that we have the appropriate clear zones. If we don't have the clear zone, we have appropriate speeds. We have appropriate protections if we can't get stuff like that. It starts making those decisions very critical. Most of the crashes in Florida are from Florida residents. They're not from visitors. 69% of lane departure crashes come from males. It's mostly in dry conditions. And lighting conditions, it's 50-50 sort of. You got 40% for dark and dark but lit. But in 6% other, 52% daylight. There isn't a clear pattern there. And then looking at number of lanes, one thing we want to be careful with this is a crash allocation and not a crash rate allocation, right? So, and I'll explain that. So when we say 24% of our crashes happen on 6 to 7 lane facilities, 39% happen in 4 to 5. Are 4 and 5 lane facilities more dangerous for run off the road crashes than 6 and 7 lane facilities? Anybody want to give that a shot? Yeah. So not necessarily is the answer. Because when we get into it, if we divide the number of crashes by the lane miles, what we find is that 4 and 5 lane facilities are much more prevalent in our system than 6 and 7 lane facilities. So when you look at the exposure that someone has to a 6 and 7 lane facility, that 24%, while it is less than the total overall, it starts to really climb in the crash rate for that facility type. Same thing with 2 and 3 lane facility, especially as we start widening our state roads, the number of 2-lane roadways starts to decrease significantly. And then if you get down into, say, context, C3Cs, 32%, C2s, 29%. So how much of our facility is a 2-lane roadway and a C2 context? So we start looking at that exposure level and where it's really coming on, because the context and roadway type is a risk factor. Posted speed, higher speed, it's not shocking, right? Higher speeds lead to more issues. Shoulder type, 67% paved, 23% curb and gutter. So does 67% paved shoulders mean that they contribute and they are a risk factor to lane departure? Probably not. There are some theories in some locations that by making the road safer, speed increases. I think that's it depends, and that's a very nuanced judgment call. What it really means is that most of our facilities have paved shoulders. The vast majority of them do, because it's not looking at the width of the paved shoulder, it just matters if it exists in that analysis. And that's the difference, right, between data and analysis. Like, we can have data on that, but being able to understand what the data is taking and what conclusions you draw from it is the analysis portion. That median types, and then started breaking down based, and once again, this is just off the data. What is coming up as a prevalent risk by district? So District 4, you're looking at you're very urban, so you're looking at C3 and C4 context class, 4 to 6 lane roadways, under 45 miles per hour. It looks like all shoulders, whether they're curb or gravel, curb and gutter, and then it looks like your larger medians from 16 feet on start to become your locations that you really start seeing run off the road crashes. Intersections. There's a lot with intersections, so it's not going to be exclusive. But looking at traffic control devices, are you signalized or unsignalized? And in this day and age, you could probably add roundabouts to that as well. Do you have turn lanes? What's the skew angle? Skewed intersections usually cause more problems than intersections that come in perpendicular. Do you have advanced warning signs? Are you inside a curve? Is there a large development? Are you in a rural area and then all of a sudden you come across a side street that has access to a development? What phasing is in your signals? What type of signal heads? Do you have back plates, right turn on red? What decisions have you made? So all of these can be risk factors in what you're looking at. And we do not have on a quick transition, we're going to go straight to bike ped with the root cause for intersections. And this is where that judgment comes in, right? We worked on doing root cause for intersections. The problem with that is the data availability and being able to narrow down, because there's so many factors that go into an intersection. We're not able to get a good root cause analysis currently. Because we don't have access to to be able to track the sheer number of factors in an intersection and then be able to do a good statistical analysis, right? The RCI only has so much, traffic ops databases only have so much. So with intersections, we have to rely on judgment as well as some of those small features that we do know are problematic. And we can find things like that through, like, say, protected phasing. We know that if you go from permissive to protective phasing based off the CMF clearinghouse, it prevents 99% of left turn angle crashes at that intersection. So pedestrians, ped volumes, there are a lot of pedestrians out there. Is it controlled or uncontrolled intersections? What type of that intersection is it? Is it marked or unmarked pedestrian crossings? Do you have a pedestrian signal? What does it look like? Sidewalk presence, lighting, bus stops, certain communities, if they more disadvantaged, if they have, fewer car households, things like that, we find that those start to pop up in our data analysis. The adjacent land uses, mixed use development versus very specific development, schools, commercial or alcohol establishments. I have seen where we were doing a roundabout analysis in Okeechobee, and we kept running into a lot of crashes involving drunk drivers. And when you started reading through the narratives, it was all a singular bar. The cops, there was a bar maybe a half mile down the street, and everyone's coming out of that and getting hit at the intersection or hitting other people. So when we look at the pedestrian root cause, mid blocks for pedestrians, at least, is where we see the most crashes, right? And it makes sense. And that's also partly an exposure issue, because people don't seem to like to cross at intersections because there are a lot of conflicts. I think people believe when they cross at a mid block, they can see traffic and they can make a better decision. They only have to worry about traffic coming from one direction at a time. But because of that, everyone goes there. And we've got 74% of pedestrians that are hit at that mid-block crossing. 56% in non-daylight conditions. So it's a reasonable split there. In terms of context, your C3Cs and your 4 to 5 lanes and 6 to 7 lanes are by and large the worst, right? C4 is in there as well. A lot of that, I think, comes down to partly its exposure. Where are the pedestrians? And then part of it too is how the roadways are designed. A lot of times in the C3 contexts, our roadways were have begun to industrialize or begun to urbanize around it, but the roadway is still built as more of a through movement. I think of US 41 as an example where it's meant as a major north-south movement, but then everything grows up around it. So then how do you transition from that predominant SIS facility to also be safe with people that are using it in a non-SIS manner? Once again, us guys are the ones that get hit the most, right? 72% of the pedestrians hit are male, 88% of bicyclists are male as well. And then when you come to the driver, we're getting hit by other males, 66%, right? Females are still there. It's a little bit in the older years as well, you know, looking at the 40s to 60s. And then in the bicyclists, they're a bit younger. Drivers are all fairly young, and they're being a part of that crash. And we just start to break it down a little bit more. Passenger cars versus pickups and SUVs. Once again, understand that these numbers are not rates. We're looking at the total amount. So when we look at a passenger car, 50% of crashes being involved in 50% of pedestrian crashes, and a truck or SUV in 35%. We're not looking at the share, the roadway share of how many cars to trucks are there. It's just the pure numbers at that point. So the suburban commercial context class is overrepresented. C4 is overrepresented. Posted speeds of 45 to 50, and then 35 to 40 are also overrepresented. So what we're looking at, and this is where we start to add the network in, right? This is where we start to look at the exposure. So with this, the C3Cs, you have 41% of your crashes happen on them. They're only 19% of the network. So you have a severe overrepresentation of the crashes in that area. 47% in the 45 to 50 miles per hour, it's 24% of our network overrepresentation. The C4 context class, this is probably pretty applicable to you guys. 34% of crashes happen there. It's only 9% of our network. So you can see that there's a massive overbalance in this. And with 35 to 40, 32% of crashes, 12% of the network. I believe that when you start getting over 50 miles an hour, it starts to be places where pedestrians aren't, and it's a much smaller percentage of the network, so you're not going to see it show up. But it's very clear that when we're talking about severe and fatal crashes, anything over 35, and you'll see the crashes and the statistics on that once we get to the speed calming, you'll start to see that once you get over that speed, survivability starts to drop off. So then it starts to become a question, like if we know that people are going to get hit, and we know that pedestrians are here, they're exposed, what decision should we be making about the speed that's on the roadway if we're following a safe systems approach? You know, should we, if we're following a safe systems approach and we know that it's effective, should we not be looking at speeds through those areas that are survivable, in addition to whatever else we're doing, but looking at survivability? Roadways with 5 to 6 travel lanes, 43% severe and fatal injuries with 19% of the network. 3 to 4 lanes is a little bit closer. It's 43% of crashes with 73% or 37% of the network. 72% of severe and fatal crashes occur on roadways with transit routes. So when we talk about transit being a risk factor, if there is transit on your project, it is a significant risk factor in what we should be doing to accommodate pedestrians.
Nathan, one thing to add to that, when we did the ped bike network screening statewide about 3 or 4 years ago, transit being on your network is a big thing to note. In District 4, that's probably going to be a lot of them. And then high frequency routes. So if you have in your peak transit periods, if you have headways less than 30 minutes apart, that really is differentiated from where you have transit that's on like an hour headway. So just something to keep in mind in terms of risk. If you're doing a project where you have a high frequency transit route, there's going to be a lot of ped bike activity there. That's why the service is more frequent there.
So the other thing to note is we start getting into socioeconomic demographics, right? So looking at percentage of the population over 65, percentage of households below the poverty level, percentage of the population with disabilities, percentage of minority population, percentage of population with limited English proficiency, and percentage of households with no vehicles. And this is a data-driven analysis, right? Census tracts with 4 or more of those factors have twice as high rate per population of fatal and serious injuries than census tracts with under 4 of those factors. So when we start looking at risk factors, the community around and who makes up that community from the data makes a really big impact, right? It's twice as high, twice as many fatal and serious crashes in a community that has 4 or more of these factors compared to 4 or less. I like these analyses because it really starts to break down so we can make the decisions once again to get ahead of crashes instead of waiting for them to happen. Sorry. So looking at top vehicle crash types, bicycles fail to yield mid-block, bicycles fail to yield signalized intersection, motorists fail to yield mid-block, motorists overtaking bicyclist. So when we see fail to yield, right, we should not dismiss it. Part of it is this is entirely reliant on witness statements and whatever the analysis that the law enforcement officer does at that time, right? There's always room for error there. And the second part of that is that remember we understand that people aren't going to make good decisions. So if someone fails to yield, they're usually not deliberately stepping out in front of anyone. What we are looking for is maybe they didn't see the gap, right? Maybe they were looking in a different area. Because if you think about it, if you're pulling out in the car, for instance, just use that as an example, and you're looking at a full meeting, you're looking at people coming this way, people across the street coming at you, people stacked up. You're having to look in a lot of different areas at once. So that goes into how we work at making those decisions easier. So even though they failed to yield, looking at things, for instance, like protected crossings may be one of the solutions that could be used in that. And then we can see by and large that crossing a roadway vehicle not turning, basically just going down the road, and a pedestrian's crossing the roadway and they get hit. And whether that is the person not paying attention, the pedestrian not paying attention, it doesn't necessarily say. But you have to remember that jaywalking is not a thing in Florida. Essentially, every side street or driveway is legal crossing in Florida. You have to be directly between 2 adjacent signals before you have to cross at a signal. The way the law is set up, even if there's a signal next door, if you're at a side street or driveway, it is a legal crossing. The pedestrian can step, as long as the driver has time to stop, the pedestrian can cross and the driver must yield. So I know there's a tendency sometimes to blame the pedestrian on this, but honestly, a lot of this ends up being a driver's issue of drivers not yielding or drivers not seeing the pedestrian. The pedestrian, when they're crossing, is often entirely within their legal right to do so. So looking at the big crash problems, pedestrians getting struck by motorists at mid-block, 41%. Pedestrians getting struck through motorists at intersections is 20%, and then pedestrians getting struck by motorists conducting turning movements is 8%. So really, it's coming down to are the drivers seeing this? Are pedestrians picking good gaps? But ultimately, as long as the pedestrian, going back to that, as long as the pedestrian is not darting out, and you see that dash dart, as long as they're doing their part, it's relying on the drivers. The drivers have the legal obligation to see them and make sure that they stop. So application. I know that was a little bit of a long session, 3 slides, and we'll have a pause. So systematic is like if you have diabetes and you're prescribing medicine at the time of the diagnosis. All right, you already have it. Now let's look at your insulin. Let's look at whatever to try to deal with it. Systemic, or the risk-based methodology, is identifying the risk factors that lead to diabetes. Looking at your insulin sensitivity, your BMI, and then applying the appropriate countermeasures, which could be modified diet and exercise. Right? We don't want to always get to treating the disease, symptoms. We want to preventing the disease from happening. The same way on our roadways. So the benefits, it identifies a problem on a system-wide analysis based on a variety of data. It looks for roadway characteristics, surrounding area characteristics, solve it. Focuses on one or more low-cost countermeasures. Now, as I said earlier, with the risk-based method, they might be high dollar, and you're going to use that risk-based on the project level. Then identifies and prioritizes locations across the network for implementation. But ultimately taking away that we're making sure we are, and I'm going to say this, I'm going to keep repeating myself, but we're going to make sure we're not just treating the crashes that show up, right? We're going to prevent them from happening. The only way to get to zero is to stop chasing our tail and stop chasing crashes. When we leave a project, when it gets designed, when it gets built, we need to make sure that we don't have to come back to it later to solve crashes. We want to make sure that that project is safe and we can move on to other projects. So FHWA, just to give an example of cost, when we get to the systemic, you could treat one high cost curve for $500,000, or you could treat 20 locations for an average of $25,000. When you do the multiple locations, with the systemic at least, while you may not solve every crash at that location, when you look at the whole, that's what you're looking at. One conversation I remember having with someone, we looked at our district. We looked at all signals with angle and left turn crashes and compared it to the protected and permissive phasing of the signals. And we came up with a list of every intersection with protected. We narrowed it down to permissive phasing, right? Because our systemic countermeasure was going to be protected phasing. And when I sat down with the signals engineer at the time and said, hey, look, like we want to talk about which one of these we can change the signal phasing on. His response was, okay, I like these, but these right here, like there's only 4 crashes at this intersection. And there's only 3 crashes at this intersection. Like I think some of these, like we need to come up with a threshold to where if it's under a certain number of these crashes, we don't do it because it's not enough, right? The problem though with that mentality is, like a T-bone, for instance, in this specific case, is a high risk crash, right? The difference between a fatal and serious injury versus you walking away may only be a foot, like the car hitting behind you versus hitting right on you. So what we pointed out was that works if we did his method, we may solve 120 crashes. But if we looked at protected phasing for every location that has a crash, we look at preventing 1,300 crashes across the entire network. And that's where that starts to come in. When you start to get that economy of scale, sometimes if you only look at that small piece, you're not getting the biggest picture. And maybe your project is that small piece, but if it only saves 1 or 2 crashes, but it's got the characteristics that could easily turn into a serious injury or a fatal crash, maybe we do something about it anyways, because that's the only way we're going to get to zero, right? The only way to get to zero is to stop the 1s and 2s. A good way to think about it is budgets too, right? A lot of times in our personal budgets, it's not the big dollar items that kill us. Sometimes it is, but a lot of times it's realizing like, hey, the Amazon vehicle has come to our house too much, or it's, we got too many stuff. It's the smaller purchases that add up. And it's the same way with crashes. Sometimes you get that big hit where it's like, hey, something really needs to happen at this intersection. But then the other times you're dealing with that 1,000 paper cut idea where you're bleeding out 1 or 2 crashes here, 3 crashes here, 1 crash there, 4 crashes there. And it traditionally hasn't been enough to address. But when you look at it from a district level or from a state level, those crashes really add up. So any questions on that risk-based systemic analysis?
Yeah, Nathan, I had a question about the there seemed to be a pretty high chunk of unusual or unknown circumstances. Like what would be an example of something that's classified in that manner for the pedestrian crash?
Ben, I'd like Ben to step in after I respond, but I think a lot of those are where it's from the narrative, or maybe like an officer rolls up at the last after the crash has happened. Hold on, I'm reading what he says. Okay. It's not always clear about what happens, or it's not expressly defined. Ben, do you have more information on that?
So sorry, I was typing the earlier thing during the question. What's the exact question here?
So like with pedestrian crashes, a lot of times there's an other categorization. So he's wondering,
Yes.
why is it other?
So as in the non-motorist is an other type of non-motorist? Is that what you mean?
No, so like we have certain crash types that are categorized. Sorry, did you want to go ahead and state your question instead of me trying to repeat it?
Yeah. There was two different there was actually one that said unusual circumstances and one that said unknown circumstances.
You're talking about the PBCAT coding?
Yeah.
Okay, got it. Yeah, we're just starting to approach that in the safety office where we do the analysis. We at least my personal experience with coding that is that if there's any kind of reasonable determination of what was going on, we use that to determine it. It's really unusual circumstances is really something that's outside of the list of options we have. And we try not to use unknown unless it's just a body laying in the street. And that's all the officer gives us, right? So yeah, we do our best to try to characterize it, but unusual circumstances would, I did code something like this recently. What was happening? Well, I don't know if I used unusual on this one, but like when there are two kids in a car, one gets out and is somehow somewhere behind the car and gets run over it because the other kid slipped it into neutral. That's kind of an unusual circumstance. Yeah, but we are working on better guidance for our analysts on how to make those decisions. So yeah,
it kind of boils down to there's specific categories that we have that things fit through, right? Once we get outside those categories, then it becomes what knowledge do we have to further categorize that? And if we can't come up with something, like we don't want 400 different categories, so if we can't come up with something that's clean, it's going to go into something like that.
I guess it's easier to say the other possibilities other than unusual are crossing from the left, crossing from the right, crossing from an unknown direction, parallel path, same direction, parallel path, opposite direction, stationary. That's about it, right? And then we have other unusual and we have unknown.
Any other questions? So one thing that I don't think we looked at, but I do want to drop it from personal experience when we start talking about risk factors, and the idea that, and this goes back to the countermeasure versus design idea, right? Like we're used to thinking in the terms of countermeasures. Let's fix the problem. Well, when we're trying to prevent it, there are other things that are preventative measures. So like transit, for instance, transit is, I don't want to say it, but like transit is a countermeasure essentially. Because when we start, if it's done well, it's also a risk factor, right? Because as it drops pedestrians off, if the facilities cannot accommodate them and cannot accommodate them crossing safely, then it's a risk factor. But where it's a countermeasure is when you're looking at people in the vulnerable user population, like elderly, for instance. My grandfather, I bought him new tires the other day. His tires it looked like someone had taken a knife and shredded his tires when I saw him, and he was driving on it. He was going to continue driving on it because he doesn't have an option. When we were doing the lane departure root cause analysis. There, we were reading through narratives. There was a significant portion of those crashes that were medical events. And you start to ask the question about like, okay, well, if you hear where like witness family was there and they're like, oh yeah, he knew he shouldn't be driving. Or he knows he blacks out under this medication. And it's like, well, then why are you driving if that's the case? And what it boils down to, aside from the independence question, a lot of our communities are not set up to do anything except for drive. You have to drive. If you don't live near family that can take care of you, can't afford someone to take care of you, and there's not transit available. So that's a case where like thinking outside the box of transit being a countermeasure. In that case, that it's our Safe Mobility for Life. We have a coalition, statewide coalition for that. That's where you start getting into those extra things that are still countermeasures, and it's that holistic approach for dealing with safety on the roadway. Right. So the next section is going to be a refresher on purpose, the safe system approach. So we're going back to that. So just remember, we're going to go back over this, right? Traffic deaths and severe injuries are acknowledged to be preventable. We can prevent them. We're going to work to that. Human life and health are prioritized within all aspects of transportation systems. So what does prioritization mean? Prioritizing means there's not a trade-off. We're not trading operations with safety, right? We're making it safe and then optimizing everything else after it's safe. Acknowledging that human error is inevitable. We know people fail, and we need to design systems. If we're going to get to zero, we have to design systems that accommodate that failure. Safety work should focus on systems level changes above the influencing individual behavior. We're still going to work on influencing behavior because we want to hit all aspects of the safe system, but understand that if we can build the intelligence into the system and make the system fail-proof, it's more effective. And then speed is recognized and prioritized as a fundamental factor in crash severity. If there is one thing you can do with all of your projects, it's reduce speed. We start getting into low speed, like two-way left turn lanes start to make a lot more sense. They start working well. High speed two-way left turn lanes are horrible. Lane widths, same way, pedestrian features. So it's making sure that we have an appropriate speed, not by how fast people would like to go or in an ideal world, but by the speed that makes sense. We recently worked with FHWA on a speed setting guidance, and one of the things that they weren't quite ready to introduce, but we did a literature review. There's a lot of countries out there that are doing what's called the injury minimization technique. So where we look a lot at existing speed patterns for data, which by the way, MUTCD and the speed setting guidance is changing to look at a six-factor approach. Some other countries are using what's called an injury minimization approach, where they're looking at like what injuries are out on this roadway. If we look at historical crashes, what do we see a lot of on this roadway? Looking at risk factors, what injuries could we predict? And then they say, okay, based off of what crashes we're seeing, what speed is survivable? And then that's their maximum speed. It's entirely based off of what they're seeing from crash results and what people can survive, as opposed to another traffic engineering formula. Once again, traffic deaths are inevitable. They're not. We're going to prevent them. Perfect human behavior is traditional approach or reliant on the user. We're going to integrate that in our approach. We're going to build systems that catch the failures. Preventing collisions versus focusing on fatal and severe crashes. It's important, right? Because we focus on all crashes, our attention is not going to be in the places that are going to always, or they're not always going to be in the places that produce the most fatal severe crashes. We want to focus on that. Individual responsibility versus systems responsibility. It's not the user's sole responsibility. We all have a role in it. And then we're not going to look at it as expensive. Saving lives is going to be cheap. Safe systems approach. Remember, safe roads, safe speeds, safe road users, crash care, and vehicles. We are responsible directly for roads and speeds. So 2 of the 5 pillars we are directly responsible for. And then with Target Zero, we are also working on safe road users. Death and serious injury is unacceptable. Humans make mistakes. We're vulnerable. We're very squishy. Just remember we're squishy. That's the one thing. If I can just, if we can all leave with squishiness. Responsibility is shared. Safety is proactive. Redundancy is crucial. We cannot survive crashes with motor vehicles. We can't. In fact, fun fact, the term jaywalking came about when motor vehicle adoption was starting to happen in our major cities. And there started to be laws considered to limit either the speeds or the horsepower of motor vehicles in cities, because the streets belong to people in the community. Motor vehicles were going through and you were starting to see pedestrians die. So the auto industry, as a response to the upcoming legislation, wanted to get out ahead of it, because they felt that if the legislation passed, their business structure would collapse, and adoption would decrease. So they would hire people, like clowns. A J was like a redneck hick type term back then. They went through this entire public campaign to convince people they should only cross at crosswalks, that you shouldn't be in the street. So when we have that mentality, when we talk about that, that is all because people started dying and an industry decided that they wanted to pursue their business model more than they wanted to protect people. But our responsibility, right, is to get out ahead of it and build that redundancy in and share the responsibility and make sure that it happens. Who's involved? System managers, vehicle manufacturers, law enforcement, post-crash personnel, and system users. System managers is us. Planners, designers, builders, operators, maintenance workers. Everything we do touches this. Every person at every level has the ability to work on this. Even right of way, right? I used to be involved in a lot of right of way conversations for eminent domain takings, where we'd have to determine access, and in order to make a deal with the property owner to decrease the amount that the state owed them, sometimes the state, there'd be decisions made that weren't always the safest decision. So we're approaching things like this. We understand that everyone has a role. Like, those decisions can be made differently. We can make different decisions in our day-to-day lives and how we're doing things to do that. Ultimately, accommodating mistakes and keeping impacts of the human body at tolerable levels. If we do those two things, we can generally succeed, because we have safe roads. Like, our roads aren't generally fundamentally flawed, right? It works with the physics. It works with users that pay attention and do what they're supposed to do. The problem breaks down when people don't do what they're supposed to do, and that's where we got to design for it. We are not unknowing how to do this. So separating users in space, separated bike lanes, for instance, in time. Look at leading pedestrian intervals, getting the pedestrian out there first. Increasing attentiveness and awareness, signage, right? Striping. Manage speed calming techniques, manage impact angles, changing those conflict points from an angle crash at a regular intersection to a rear end or a side swipe at a roundabout, and providing for safe recovery. We're creating layers. I want to show too that other industries, what we're asking of our people to do, because I know sometimes it's frustrating, like, how do we design for people? Other industries do it. It is possible. So the auto industry has a lot of active and passive safety, whether it's active safety such as lane departure, keeping lane keeping assist, and cruise control. There's a number of different things going in. And then when we look at, and this is one of my favorites, talking about OSHA, like, because OSHA has done something. OSHA is industrial engineering, and OSHA has done exactly what we are doing. When you look at how they set things up, OSHA is entirely dependent on it's on human behavior and interacting with the environment, understanding like what people are going to do. They're going to make mistakes. Like a perfect factory worker is not going to stick their hands in a machine where it's not supposed to be. But people are going to get in a hurry and they're going to do it. So if we think about like fall protection, so we're going to eliminate the exposure to that fall completely if we can. If we can't, we're going to replace it with something that lowers that severity. We're going to make changes to how we operate it. Administration controls, and finally PPE. PPE is, in this case example for vehicles, would be like airbags in the car, right? So if you think about how you're going to protect from a fall from OSHA, you're either not going to let the first thing is you just don't let people around the fall hazard. You're just not allowed to be there, right? If you have to be there, what are you going to do? Okay, let's rope it off. Let's provide some protection. The next thing that we can do is we can say, okay, now you have a harness. In addition to not supposed to be getting close to it, we're going to hook you into this harness that's going to help hold on to you. But then they don't really need that if they don't slip either, right? So being able to put hand railings to hold on to, or non-slip shoes, or being able to keep, say, oil or slippery surfaces out of that area. So you essentially, you design that system to where if any one of those things fall, if you slip, the arresting system catches you. You know, if for whatever reason the barrier fails, that you have a handrail and you have non-slip shoes on. But there's ways that as the system goes, they're building in ways to protect people when the failure inevitably happens. And what we're trying to communicate is that we can do the same. We just have to change how we're approaching it and make sure that we are truly prioritizing safety and making it our highest priority, and then optimizing everything else once safety is accounted for. Any questions? Okay. Go ahead.
I have a question.
Mhm.
This is the first day. So just to be clear, at one point in this safety academy, you'll be talking about how we can actually do this in our daily lives at work with it being acceptable if we have suggestions or something in our work.
So I think there's two questions there. I think the first one is, are we going to learn what to do? And then it sounds like the second one is it going to be accessible for us to advocate for this? Is that correct?
Yes.
Okay. So the way we're approaching the academy, because we want to pound the safe system approach in, we're going to be delivering a module entirely on the safe system, and it's going to talk about a little bit more about some of those ideas. The determination of countermeasures is getting into thinking through not just doing like formulaic if X then Y, but thinking through like, why are we applying these countermeasures? Not just saying, hey, it tells me to, so I'm going to do it, but how are we putting ourselves in the user's seat when they're driving, or shoes if they're walking, and making those decisions, looking at the crash data. And then we're going to get into, it's going to largely on countermeasure based, but intersection safety, bike ped safety, lane departure, and speed calming. And then with that knowledge, because I know it's still going to be a little bit fragmented, we're going to be on hand on the 29th for the workshop to actually to be there to walk you through putting it all together and making that happen. As for the advocacy portion, I think that's a personal decision on your point, on your part, right? We can always advocate. It doesn't mean we'll be yes. There's a program to manage. There's other people that are making decisions sometimes, and there are sometimes realities that we have to face. So there's going to be times when we want to do something and it's not always going to work out. But I do think that part of you being here is so that you're one of the voices saying, yes, we should do this and we need to do this. Because sometimes it's just a matter of asking the question and it happens, right? Sometimes it takes a little more effort and a little bit more pushing or building consensus on it. But I also would imagine that if everyone that works for the department, our local partners, if we believe in target zero and we believe that it is our moral imperative and we can make a difference and we are working towards that, I think we'd start to get to yes a lot more often than we would think. Plus, I think if you're running into a problem, I don't want to speak for Tracy, but I might a little bit. I'd imagine if you're running into a problem on a project, you can always reach out. Like I said, Tracy can't do everything on every project, but it may help to have their support in the conversation. Any other questions? All right. I appreciate everybody's time and attention today. If you do have any other questions, feel free to email them. And then we will have the same formula on next Tuesday, the 7th, where we will be looking at the safe system approach and determination of countermeasures.